Welcome back to the 60-day Cloud Security Challenge. Yesterday we covered cloud computing fundamentals. Today we are getting hands-on with AWS. You have a fresh account, your credit card is on file, and you have root access. Before you launch a single EC2 instance or create a single S3 bucket, there are 6 things you need to do. I have seen production AWS accounts with root credentials in shared documents, no MFA, no logging. That is how breaches happen. Let us make sure your account is not one of them. Step 1 is the most important. Enable MFA on the root account. Root in AWS is not like root on Linux. You cannot restrict it with policies. It can close the entire account, change the billing email, access every resource. There is no guardrail that applies to root. So you need to protect it with multi-factor authentication. Go to IAM in the console, click your account name, and enable MFA. Use a hardware security key like a YubiKey if you have one. A top app like Authy is your second choice. Never use SMS verification. SIM swapping attacks are cheap and effective. An attacker calls your carrier, social engineers the support rep, transfers your number to their SIM, and now they get your MFA codes. With a hardware key or TOTP app, that attack vector disappears entirely. Step 2. Create an IAM admin user. After MFA is on root, you should almost never log in as root again. Create an IAM user, attach the administrator access managed policy, and use that for your daily work. Yes, administrator access is still very broad. We will tighten that up on days 3 and 4 when we cover IAM policies in depth. But an IAM admin user is fundamentally safer than root because you can revoke its access, you can track its actions separately in CloudTrail, and you can restrict it with service control policies if you are using AWS organizations. When you create the user, set a strong temporary password and require a password reset on first login. Delete any access keys on the root account if they exist. There is almost never a legitimate reason for root to have programmatic credentials. Step 3. Turn on CloudTrail. CloudTrail logs every API call in your account. Every time someone launches an instance, uploads a file to S3, assumes a role, or changes a security group, CloudTrail records it. Without CloudTrail, incident response is impossible. You are literally guessing what happened. Create a trail, point it at an S3 bucket, and enable 2 critical flags. First, make it multi-region. AWS has dozens of regions, and attackers specifically target regions you are not watching. Second, enable log file validation. This creates a chain of SHA-256 hashes so you can mathematically prove your logs have not been tampered with. One thing to know, CloudTrail has a 5 to 15 minute delivery delay. The events happen in real time, but the log files land in S3 with a lag. For real-time alerting, you will eventually pipe CloudTrail into CloudWatch logs or EventBridge. But the baseline trail comes first. Step 4. Set up billing alerts. This might sound like a finance concern, not a security concern, but hear me out. One of the most common attacks on compromised AWS credentials is cryptomining. Attackers spin up the largest GPU instances they can find, across every region simultaneously, and mine cryptocurrency on your dime. I know of cases where the bill hit 6 figures in a single weekend. A billing alert in CloudWatch gives you a chance to catch this early. Set your threshold low. For a learning account, $50 is reasonable. The alert uses the estimated charges metric in the AWS billing namespace, and it must be configured in EAST-1 because that is where billing metrics live regardless of where your resources are. You will need an SNS topic with your email subscribed so the alarm has somewhere to send the notification. Step 5. Block S3 public access at the account level. S3 bucket misconfigurations have been behind some of the biggest data breaches of the last decade. AWS introduced account-level public access blocking because bucket-level controls were not enough. Developers kept accidentally creating public buckets. The account-level block has 4 separate flags. Block public ACLs prevents new public ACLs from being added. Ignore public ACLs makes existing public ACLs ineffective. Block public policy prevents bucket policies that grant public access. Restrict public buckets limits access to buckets that have public policies. Enable all 4. If someone legitimately needs a public bucket later, they will have to explicitly request an exception, which creates a conversation and an audit trail. Step 6. Set a real password policy. The AWS default allows 6-character passwords with no complexity requirements. Set your minimum to 14 characters, require mixed case, numbers, and symbols. Set max password age to 90 days and prevent reuse of the last 12 passwords. That covers your Day 2 checklist. Root MFA, IAM admin user, CloudTrail, billing alerts, S3 public access block, and password policy. Do not skip any of these. Tomorrow we start IAM fundamentals where we dig into users, groups, roles, and policies. See you then.